In this concept video, we're going to be rewriting the trigonometric functions in terms of x, y, and r. And essentially what we're going to do is we're going to take a right triangle and we're going to put that on the coordinate plane. So let me draw a right triangle here for you. And we might have to extend, why don't we do that? Why don't we extend this x-axis a little bit? I want to make sure this shows up on the video for you so it's not too tiny. We'll drop that altitude down right here. So there's our right triangle. In this case, we don't know what theta is. We'll just make that our angle. We do know that this distance from here to here is going to be x. We also know that this length from here to here will just be the value of y. Also, we're going to imagine that a circle is drawn around the entire coordinate plane, centered right here at the origin. So this distance will be r, or the radius of this circle. If we just look at the right triangle itself and theta, we'll also note that y is the opposite side, that x is the adjacent leg, and that r is just the hypotenuse of the right triangle. If we write out our trig functions, we've got the sine of theta being opposite over hypotenuse. Now, when we place this right triangle on the coordinate plane, we can accurately say that the opposite side will always be y, and the hypotenuse now, in terms of a circle, will just be whatever the radius is. You'll note that even if we drew this a little bit with a different angle, those relationships would still hold true. The y direction would be the opposite side of this triangle, this right triangle, and then also the adjacent side, albeit it would be a little smaller if this angle was up here, would still be the adjacent side to theta. So it doesn't matter where the angle is, these relationships are true. We can also say that the cosecant of theta is just r over y. Remember that the cosecant and the sine have a reciprocal relationship. So now we can understand the sine as being y over r, and then the cosecant as being r over y. The cosine then, it's still adjacent over hypotenuse. But when we put the right triangle on the coordinate plane, we can also understand this ratio as being x, that's the adjacent side, over the hypotenuse, which is r. The secant then would just be r over x, or the reciprocal. The tangent, opposite over adjacent, opposite is y, and the adjacent side is x. Hopefully this looks familiar to you. This is also slope. Cotangent of theta is just the reciprocal here, or x over y. Our relationships, sine, cosine, and tangent, like the sine is opposite over hypotenuse, cosine adjacent over hypotenuse, tangent is opposite over adjacent, that hasn't changed. But what we are understanding now is that when we place this triangle on the coordinate plane, when we're imagining a circle is drawn around the coordinate plane centered at the origin, we can correctly state that the sine is also y over r, the cosine is x over r, and the tangent is y over x.